All right, let's talk about something we all use, probably every single day, those 6 little numbers in your Authenticator app. You know the ones. They pop up, they change every 30 seconds, and they're a huge part of keeping our online accounts safe. But have you ever stopped to wonder how they really work?
Because here's the really wild part, right? Your phone can be in total airplane mode, no Wi-Fi, no cell service, completely cut off from the world, and it still spits out the right code. How on earth is that possible? Is it some kind of psychic?
That's not magic, but it is seriously clever. The best way to picture it is like a secret handshake. A handshake that only your phone and, say, your Google account server know. And the crazy part is they both know how to change it at the exact same time every 30 seconds without ever talking to each other.
Now, this whole process is something we're all super familiar with. You pop in your password, the website asks for your code, you open the app, you type it in, and bam, you're in. It feels almost trivial. But today, we're going to pull back the curtain and see exactly what's going on under the hood.
So first things first, how do your phone and that server learn this secret handshake to begin with? It all gets started with a really simple one-time setup.
So you're in your account settings, you decide to turn on two-factor authentication, and you get that funny-looking QR code on your screen. The second you scan that with an app like Google Authenticator or Authy, you're basically teaching your phone its half of the secret handshake.
See, that QR code isn't just a random jumble of squares. Hidden inside it is something called a shared secret. And this, right here, is the absolute bedrock of the entire system. It's a super long, totally unique string of characters that, from this point forward, will only ever exist in 2 places on Earth, encrypted on your phone and on that website's secure server. That's it.
This image kind of shows you what's happening on the back end during that scan. Your computer asks the website server for a secret. The server generates one just for you, packages it up into that QR code, and shows it to you. When you scan it, that's it. The connection is made, the secret has been shared, and the handshake is officially learned.
Okay, so both sides know the secret, but how do they stay perfectly in sync, generating those matching codes, without ever having to communicate again? This is the most brilliant part. It's all about synchronized offline security.
You might think it's some kind of insanely complex algorithm, but the formula is actually beautifully simple. Both your phone's app and the website's server take just 2 ingredients, that shared secret key we just talked about and the current time. That's it. They both run those 2 things through the exact same mathematical recipe, and the result? The exact same 6-digit code.
This diagram lays it all out perfectly. Over on the left, you've got your phone. It takes the secret key and the current time and puts them through what's called a cryptographic hash. You can just think of it as a unique digital blender. Now over on the right, the server is doing the exact same thing with its copy of the secret and the time. And because the ingredients are identical and the blender is identical, the result, that 6-digit code, is always identical too. No internet required.
I absolutely love this analogy. It just nails it. They're not talking to each other at all. They're just 2 perfect clocks set to the same time, ticking along in perfect unison forever. And that shared secret is what ensures their chimes always match.
And that's where the time-based part of the name, TOTP, or time-based one-time password, comes in. The algorithm doesn't use the exact second, it uses time in 30-second chunks. So for that entire 30-second window, the code stays the same. But the very instant the clock ticks over to a new 30-second block, the time ingredient changes and poof, a brand new code appears, making the old one completely useless.
All right, so your phone has its code. You've typed it into the login box. What happens on the other end? How does the server actually check if you're right? This is the moment of truth, but it's actually the simplest part of the whole process. The server has already done its own calculation. It already knows what the code should be for that 30-second window. So when your code arrives, it's not doing any complicated decryption, it's just playing a simple game of match.
If the code you sent over matches the one the server came up with, you're in. Welcome back. If it doesn't match, maybe you were a second too late and the code changed, or you just fat-fingered a number. You're denied. It is that simple. It's that equals box from the diagram. It's a binary, yes or no question.
So now that we get how it works, we have to ask the big question. Why is this so much better? Why do security experts tell us to use these apps instead of just getting a code sent to us in a text message?
And look, it's a totally fair question. SMS is convenient, right? Your phone buzzes, you get a code, you're done. But that convenience comes with some really serious security flaws.
Let's just put them side by side.
Authenticator apps work offline, and that all-important secret key is locked down on your device. SMS, on the other hand, sends the code over the cell network every single time, and that makes it vulnerable to being intercepted. But the real killer is SIM swapping. That's where a hacker tricks your phone company into moving your number to their phone. If that happens, they start getting all your login codes. Authenticator apps are completely invulnerable to that attack.
These advantages are massive from a security standpoint. Because the code is created on your device, it can't just be plucked out of the air. And since that secret key never travels over a network again after you first scan it, it's so much harder for a hacker to ever get their hands on it.
And really, it all boils down to the single crucial point. To get into your account, a hacker now needs to solve two totally different problems. They need your password, which they might get from a data breach online. But they also need to physically have your phone in their hands and unlocked. That's what raises the bar from difficult to next to impossible for most attackers.
And that's really the thought I want to leave you with. In this day and age, you have to assume that your password can and probably will be stolen at some point. So the real question you have to ask yourself is, what's your second lock? What's standing between a hacker and your entire digital life?